Hello everyone. Before deep dive into the Linux kernel device driver, I thought it would be great if we learn Linux kernel cross compilation steps in detail. So in this video, I'm going to cover kernel cross compilation steps in detail. What is cross compilation? Why do we go for a cross compilation? Mostly in embedded system uses ARM architecture. Nowadays, 90% of the embedded system uses ARM architecture. In PC market, it uses x86 architecture. So if you are building your kernel in x86 machine, it will generate binaries for x86 architecture. For example, if I have a custom Raspberry Pi board, it uses ARM processor. The same x86 binaries will not work on my board. So I have to cross compile my kernel source for Raspberry Pi board. Basically, cross compilation means compiling code on one architecture to run on a different architecture. In our case, in x86 machine, I am going to build my kernel for Raspberry Pi board that uses a ARM architecture. Below are the tools and dependencies for cross compilation. We need a Linux machine like Ubuntu. Then we need a cross compiler for ARM architecture. Then we need a kernel source from kernel.org if you need a plain vanilla kernel. Then if you want Raspberry Pi kernel, then you can directly download it from Raspberry Pi website. Then we need a couple of tools to make a cross compilation. Then lib and curses is mandatory for kernel configuration. If you want to do menu config and all, you must need lib and curses. Then you can through sudo apt install, you can install your ARM toolchain. To get the kernel source code, you can use below links. If you want to download a plain vanilla Linux kernel from kernel.org, you can use the first link. This is the stable and latest version. Or if you want to get the Raspberry Pi's kernel version, you can use directly Raspberry Pi's website, or you can use below git link for to download the Raspberry Pi kernel. You can do both the experiments actually. You can directly download a plain vanilla kernel from kernel.org and you can make a cross compilation for your Raspberry Pi board, or you can directly download it your kernel from Raspberry Pi website. Then you can make a cross compilation for your board. So the main difference from vanilla kernel is it may not work all the features on your board, as it may need some additional architecture specific changes. But if you are downloading it from Raspberry Pi website, they might have already done all the architecture specific changes so that all the features might work on your board. Below are the cross compilation steps. First, you have to export your architecture. Here we are using ARM architecture. Second one is you have to export your class compiler. The first two steps will tell that we are not using x86 machine, so we are going to use ARM architecture for this compilation. Then you have to do a default configuration for your Raspberry Pi board. Raspberry Pi board uses Broadcom chipset, so we are using BCM2835 underscore def config. So this will do a default configuration for your Raspberry Pi board. Then you can do make menu config. This is optional actually. So if you want to enable or disable any feature or any driver, then you can use make menu config. Then finally you can use make minus j, then your processor number. If you are using 8 processor, then you can use make minus j8. This will generate the kernel images and DTB under arc arm boot folder. Here I am going to explain the same step in practically. So I have already downloaded Linux 6.15 version from kernel.org. Here is the folder structure for our Linux kernel. So let's start our cross compilation practically. First I'm going to export architecture as a ARM. Then I'm going to export cross compiler for our ARM architecture. Then you have to do a default configuration for Raspberry Pi board. Here we are using BCM2835 underscore def config. Actually Raspberry Pi board uses Broadcom 2835 chipset, so we are using BCM2835 underscore def config. If you want to see this source, you can go directly arc arm configs folder. Here you can use you can see all the default configuration over here. For our Raspberry Pi board, we are using BCM2835 underscore def config. Then you can use make menu config for kernel configuration. Menu config is basically used to configure your kernel. For example, if you want to enable or disable any feature, you can use a menu config. Similar way, if you want to enable or disable any drivers, you can use menu config. For any embedded system, you may not use all the features in your board all the time, so you can enable or disable any feature so that you can reduce the size of your kernel image. I'm going to show you some example over here. For menu config, no, libgun curses is mandatory to install. Here, if you want to enable any networking support, you can press tab so that it will enable automatically. You can see two options over here. One is star, another one is M. If it is M, then it includes in your kernel as a module. If you see star, then it will be statically included in your kernel image. Then if you want to do any file system related support, then you can directly enable or disable over here. Finally, you can save your configuration. Then it will generate on .config. Based upon the .config only, your kernel image will be generated. Then finally, you have to compile your kernel using make minus j8. 8 is for number of cores. Then I'm going to give time. Time will tell how much time the cross compilation took place. Actually, I have already completed the kernel compilation, so it has generated images for me. So if I go org arm boot folder, you can able to see the kernel image over here. You can flash this image in your Raspberry Pi board. Then to verify your kernel version, you can just enter uname minus a in your Raspberry Pi machine and check your kernel version. Thank you for watching.